Добрый день. Мое выступление будет на английском языке, вот поэтому переключаем на английский. My name is Malik Mохрат, research engineer at SberRoboticsCenter. So from the previous presentation, we understood that data, not only data, but a big amount of data plays a very big role for a successful training of foundation model. Here we are speaking about navigation foundation model, right? So we will speak about the data for this navigation foundation model. So what is visual navigation data? Basically, it's like a sequence of or a group of images where we have like our current image and the goal image, right? For each of these images, we should have its ego motion or its pose so that we will have a trajectory out of this. So based on this, we made like a plan for us to find as much as data miners, where we are able to process any kind of video and kind of requirements. So we have like to process every 1 hour, 1 real video hour in a ratio like 1 GPU hour. So we are monitoring how the foundation models shows like big performance, such as like SAM, Clip, or even ChatGPT, because they are like not only perform well, but also show some kind of side effects or emergent behavior. For our case, like in navigation models, we have like the ability to explore, not only to go to the goal. That also needed for kind of fine-tune for specific tasks. So we also need data to fine-tune the models. Basically, for navigation models, there are 4 basic sources, which are humans, robots, simulators, or videos from video hosting platforms. We are trying to mine data out of all these sources, process them, and to have, at the end of the day, trajectories. Let's start and move for them one by one. Let's start from like training data captured via humans. Basically, one of the best examples is the data set of Sampo. As we see in the slide, here, like a human, attached to him 2 cameras, one on the chest, another on the head, and he is walking around. Here we got around 11, and that's it, 11 hours of human navigation. It's an outdoor data set where we have varying weather, time, and ego motion types during the movement. Another type is data sets from robot platforms. One of the interesting examples is the model that Evgeny talked about, which is Vint. Vint, actually, which is a foundation model, trained its model on several data sets. These data sets were captured by 8 different robo platforms. Each of them has its own like characteristics of speed, dynamics. We are speaking also about different camera setups. So all the data that Vint trained on were roughly 100 hours. The third source is simulators. In our center, we are working basically on 2 of them. First one is Sim. We have made a kind of digital twin for our center. as we see in this slide, here we are not only testing our algorithms, but we are able also to mine some kind of synthetic data based on our desired conditions. And we can put virtual robots in the sensor setup that we need, and with the ability to add dynamic objects such as humans. Another simulator is a NERF-based one. We can do a recap. What is NERF? NERF basically is to implicitly represent our 3D scene inside a neural network, which is basically an MLP. Out of posed 2D images. So we have images, basic images with their poses, and we train our model to overfit over this scene. So unlike other models here, where we need to do generalization, here we are doing kind of overfitting over the scene. And the task here is to render novel views by this model from any view or direction that we wish. How we use this technology? We took a work called F2 NERF, basically having only a monocular video. Monocular video, it's like a normal video that we have. We, first of all, do either structure from motion, which is a cold map, or we run visual odometry so that we have these posed images. Then we train our NERF, and then we feed all this data to a NERF simulator. Overall task, again, to generate novel trajectories. Why we are doing so, or we are doing so, because it's a practice that being practiced even in a company such as Wavy, which is a popular company for autonomous driving. They do the same, actually. So a car move in a single trajectory, then they train the NERF, then they do kind of data augmentation over trajectory. So they do some kind to drift right and left. So by this way, they are reaching their trajectory. So out of a single trajectory, we will have plenty of them, and we can render new images out of every generated trajectory. So at the end of the day, we are enlarging and empowering our data. We do the same. We captured a video via a mobile. And after training the NERF, so the left video is rendered pictures, but NERF not only capture in this neural network not only the appearance but also the geometry. So here we see a point cloud. Why geometry is important? Because we have an algorithm to generate collision-free trajectories, as we see in the left, so that we so that we can render new views out of every single new trajectory. So the last and maybe one of the most important sources is videos from video hosting platforms. Again, why we do so? Why exactly we take video from, let's say, VK Video, YouTube, and so on? Again, we are empowering the generalization ability, and it's like open source data, so we eliminate restrictions of high cost. And the most important thing that we are speaking about scalability. When we mine data from these sites, we have a big amount of them. One more reason that videos There is a tendency nowadays in robotic community so that a video as itself, it's a kind of representer for robots to do a kind of behavior cloning. One more advance for this, for mining from these sites, is actually the diversity of the data. Here we got a question about like different weather conditions. So yeah, when we speak about diversity, we can mine video from walking person or people riding their bicycles or motorcycles or even driving on the car. Moreover, we are speaking about like videos that represent various environments, have been captured all over the world, so geographical distribution, weather condition, and different scenarios of traffic and pedestrian situations. And of course, we are speaking about several and various camera configurations. So, having these videos, how we process them. Basically, we have this simple, simple pipeline. Why I call it simple? Because it's composed of simple components. We first of all do scene boundary detection. We do structure from motion. We do also depth and semantic segmentation predictions. And we feed all of these data to a monocular visual odometry. So we have trajectories. Let's go one by one over these steps. Why we do scene boundary detection, because as I mentioned earlier, we need to feed this video to a visual odometry. As a video, it could be composed of several standalone scenes. We need to do so. We need to directly cut the overall video into standalone scenes. We do so using a feature extractor and feature matching over these frames, so that we know this scene could be for longing for some times, starting in this frame and ending in another one. Basically, we are able now to detect two basic types, which are cut, transitions, and gradual. Cut, it's like when we have a scene and directly another different scene, or gradual when we put a kind of visual effect during the montage process. So having these boundaries, we go to camera calibration. Why it's needed? Because here we are speaking about video that we don't have any clue about the camera parameters or camera information, such as intrinsics, such as its focal length, its principal points, and so on. We use the structure from motion to have a kind of estimation for camera model. We use for this call map. We do so by taking any random 300 images which are overlapping. We also do feature extraction and then matching of these key points across images. Then we build a kind of sub 3D map to reconstruct the scene by using also bundle adjustment. So after this step, we have an understanding about the camera model and about the intrinsics of the camera. We go to the K component of this of this pipeline, which is visual odometry. Here we are speaking, we know that visual odometry could be solved by different types. It could be stereo visual odometry or visual inertial odometry, and so on, even LiDAR. But here we are speaking about monocular visual odometry. Monocular visual odometry face a serious problem, which is scale drifting. Why we have scale drifting? Like the trajectory while we build it, it could like have different scales because we have ambiguity of the scale during the movement because we don't have metric information. We solved this, and it was kind of game changer. We used Zoe depth. Zoe depth is a monocular depth estimation, but metric one. So using this model, we were able to get consistent and metric depth information, which is heavily affected positively on the pipeline, and we are having kind of stable and avoiding the problem of scale drifting. So to sum up, between these 4 different sources, basically robots, like that's it, taken from robots considered to be data with the highest quality, but it costs a lot, not scalable as well. So humans and simulators, but we are speaking about less quality for simulators because it's synthesized data. So for us, it's like now it's a big open question which source to focus on, but there is a kind of tendency that we are working more on mining from videos from video hosting platforms. Why? Because it's, as I said, it's scalable, cost not so much, and the quality we are speaking about videos recording in real life, so it's realistic. As a feature directions, we are working on this, as I say, it's speeding up the mining process. And we are working on algorithms to keep only useful trajectories. When we say useful, we are speaking about trajectories that really gives new information to the robot. Like, for example, if the person keep going forward inside a corridor, it's a repetition for the data, so we can like filter these and keep only needed one. Also, we can use visual large language models for 2 basic directions: to clean up these data by removing like blurry or black frames and so on. And why not, as the previous speaker said, that we can have like text description of the scene, and it could be used for the training of navigation foundation model. Thank you for your attention.
Malik, really thank you for your presentation. We have some questions.
Hi, thank you for your presentation. During your presentation, you've mentioned that you used an augmentation technique to extend your trajectory dataset. I'm interested, have you implemented the same technique on another types of data? Thank you.
Thank you. Another type, like which type you mean?
I mean, as I understood from your slides, you used it on the data which roads are represented. I mean, you are slightly modified the data somewhere on your office or something like that.
Yeah.
Or you used it on something you received from the video streaming services.
Well, yeah, okay. Thank you. I will go in details how we do so. We basically tested this in both in outdoors and indoor scenarios. So office-like scenarios and in the roads. We do so using the geometry. So having the geometry of the 3D scene, we are able to augment the trajectories so that they will not do collision with objects. So as much as we have free space to go on, we generate trajectories in these free space to render out of them new images. So yeah, we have practiced this in both scenarios, indoor and outdoor.
Yeah, thank you.
You're welcome.
Hi, I'm actually working in YouTube and in video hosting, and my question is therefore, I'm curious, do you have any wishes to video hosting, to the formats of video representation that could be convenient for your work?
Relations?
I mean, any wishes that could help your work with creation of data sets like you just described? Because you said you use video hostings a lot, right?
Sorry, I didn't get the question.
I mean, maybe some kind of annotations on videos, maybe some trajectories, maybe some text annotations or something.
No, at all. No, at all. We barely take the video as it is, and we do the pre-processing and the processing over it, having no other thing from the video, having only the title. I mean, basic information about the video itself, but not anymore. We do so, yeah. We do semantic segmentation over it to detect dynamic objects. We do depth estimation, as I said, to solve the drift scale issue. And working on extract text description of frames on this video using LLM. I hope that I answered your question. Можно задавать вопросы на русском, постараюсь ответить тоже.
Хорошо, Малик, у меня тогда вопрос. Смотри, а вот мы рассмотрели различные варианты, а в итоге какой там самый оптимальный, потому что у всех есть плюсы и минусы, и как планируете дальше майнить данные вот, в глобальном смысле слова? Есть ли какое-то соотношение этих источников оптимальное?
Вот как я сказал, что это остается открытым вопросом, мы работаем над этим, чтобы действительно определить, какой именно источник наиболее подходящий для нас. Но кажется все-таки, что действительно видео из таких сайтов может наиболее оптимальным, ну, поскольку там это дело масштабируемо, и там в основном видео сняты в реальной жизни, но, конечно, тоже при этом можно не забывать про другие варианты, такие как, например, датасеты сняты с робота или с человека. Поэтому, если ответить на ваш вопрос, то мы работаем над всеми этими.
Да, наверное, тут еще тоже можно продолжить вопрос из аудитории, который был про пожары, всякие стихийные бедствия. На YouTube, на открытых источниках их довольно мало, и придется, наверное, подмайнивать данные оттуда. То есть, наверное, еще в зависимости от домена могут быть разные соотношения источников данных.
Да. Но в основном, то есть тоже мы стараемся найти видео с разных доменов на улице или люди, которые ходят по, не знаю, по торговым центрам и так далее.
Спасибо. Может быть, еще вопросы? Есть. Сейчас.
Да, спасибо большое за доклад. Такой вопрос. Вы говорите то, что используются различные видеосервисы для майнинга данных. Вот как в этом случае решается проблема с лицензиями? Насколько свободно можно просто взять видео с YouTube, например, и использовать для обучения? Есть ли ограничения какие-то?
Ну, в основном, и именно ради этого мы не только оттуда майним данные, в основном тоже с других сайтов. Ну, в целом, в основном наш главный источник это не является YouTube. Я могу так сказать.
Могу на русском.
Спасибо.
Да. Спасибо за доклад. Вы берете видео с хостингов, соответственно, они бывают иногда с зумом нет. И насколько вы, грубо говоря, рефайните это или нет? Или стараетесь все-таки брать фикс зум, фикс фокус, ну и, соответственно, на них гораздо проще получить интринсики камеры?
Хороший вопрос. У нас пока нет алгоритмов, которые определяют такие случаи, но судя по нашим наблюдениям, это довольно редко бывает. Но я согласен, что нужно с этим бороться.
Ну, в теории, конечно, можно какой-то классификатор от зума, статический зум, чтобы понимать, не по Z ты двигаешься.
Да,
Спасибо.
как вариант. Спасибо.